Next up in our look at data analysis in Python is a dive into how we can create data visualizations in pandas. Before we start, you should know how to work with data frames, including importing data from files, and you should really just have a general basic comfort level working with pandas. Visualizations are really important in data analysis. A list of numbers may appeal to some kinds of people, but I think most of us have trouble understanding what's really going on as we start to look at more and more numbers and as those data sets get more complex. Visualizations help us see patterns and help us recognize interesting or important data points so that we can better understand what we're looking at and better make conclusions about the data and what it can tell us. Pandas provides good charting or graphing or plotting features through the plot function and a variety of related functions. Pandas uses the matplotlib library as the back end of for all of its plotting. And if you really want to get deeper into these kinds of visualizations, you'll probably find yourself working with matplotlib directly. There are a lot of resources on that, a lot of YouTube videos and all that stuff. For us, let's go ahead and import some data and see how to generate some basic visualizations to get us started. I'll create a new cell here, and as always, I will begin by importing that pandas library, and I'll alias it to PD. And I guess before I get too carried away, make sure I have a kernel selected. I'll go ahead and run this so that it has time to get through that first execution process, everything it needs to kind of set up. And we're going to go ahead and pull in data from an Excel spreadsheet, and I've got this linked in Canvas. At the moment, YouTube won't let me put live links into my videos. If I get around to getting verified or whatever, maybe I'll add that, but for the time being, you can get this from Canvas. So we're going to make a data frame, and we're going to read an Excel file. This one is called grades.xlsx, and since I am I have the file in the same folder as my Jupyter notebook. I don't need to have a fully qualified path there. That should do it. And I'll just confirm that it's working by displaying that data. So this spreadsheet has a couple of different sheets. And this workbook, I should say, this spreadsheet file has a couple of different sheets. And the first one, we have a bunch of overall class grades for a handful of fictitious students here. Let's go ahead and make another code cell below this, and we'll just call the plot method directly and with no fancy stuff with it. We'll just call it and see what happens. So this will grind away on that data frame for a moment, and then it will produce our first visualization. Maybe I'm zoomed in a little too much here. Our first visualization. This is a good old-fashioned line chart or line graph, or I'm going to try and use the term plot. So this is plotting that data frame of students and their overall class grades. The problem is that this maybe isn't a very useful visualization here. It's not really very obvious exactly what we're looking at. The y-axis seems to be showing the grades over here because I see a range that goes from kind of 60 up to about 100. So that would seem to be the percentage grades that I get up here for overall. And then going across the bottom, I just have these numbers, and it's not clear exactly what those are. It turns out those are the rows from our data frame up here, and the numbers are the integer indexes that it has created for those rows, kind of by default, right? So that's what's going on here. In this case, those index numbers for this data frame, those really aren't necessary because we have student names, and that's probably a much better way of indexing these results because, for example, I might want to grab Aubrey's grade, and I can refer to that then with her name instead of with having to know that that's index 7. So So let's go ahead and adjust that a little bit. We'll use the set index feature or function. So I'll take my data frame and I'll call set index. And I'm going to say that the index is the student, right? That's what I've called it in my data frame up there. And then I'll output just to see what that looks like. And there's no change visually. The reason is that it doesn't realize that the student is already kind of in my data set. That's already a column in there in my data frame. So what I need to tell pandas is that the index that I want to use is already kind of in place in my data. And so the argument we're going to use is in place equals true. And now I'll run that again. There we go. So now I've got a column for my overall, and that's the index for that column. And then I've got the indexes for all of my rows are going to be the students' names, this student data here. And let's go ahead and verify that, I guess, by, oops, not markdown. Let's make a code cell. Let's go ahead and verify that just by trying the, actually, I'll just do it up here. Let's try the loc attribute here and see if we can retrieve, I think I mentioned Aubrey N was the name. Let's see if that works. I maybe have typed her name incorrectly. Run all my code again. There we go. It did work. It just had to rerun the input so that it would have that data frame set up correctly. So it's set the index to student, saying that that data is already in place. And I've confirmed that that worked because I can use the loc attribute to pull a row out of there. And Aubrey's grade is 79.58 something. So that seems to have worked. That seems to have given us kind of a custom index, right? And let's see how that changes our plot if we plot it again. There we go. So now this makes a little more sense, right? We can start to see that, oh, okay, this is Jeff N's grade. He had something, close to 100, or maybe that is 100. Janelle, Johnny. A bunch of the names are left out because they just visually wouldn't fit in that space. And the truth is that a line plot here, it's nice, it's a good start, but this isn't really a very useful way to look at this particular data because we think of line plots as showing kind of trends and things like that. Well, I don't know that I need to see the trend from Jeff to Ruben, right? They're two different people. So let's see if we can look at some of the other types of plots that are available to us. The first way we can change the way we plot our data is by just adding a named attribute here. So there's an attribute called kind, and you can already see that that Visual Studio Code is popping me up now a whole list of some options there, and some of those look pretty interesting. But we will just try a bar plot here and see how that looks. Okay, this is already looking a little better to me, a little more useful to me, because now I've got the names going across the bottom, and it's got all of them there. And then I've got these bar plots, these bars that show each student's relative grade. So this will help me at a glance. I can kind of easily identify who the lower performing students were on this particular test, or in this particular class, as well as the ones who have very high grades. So that's already an improvement. There is another way to change the kind of plot that we do. So we can do it with that kind attribute. We can also just call a function directly. So there is a bar function there that I can call. And that results in essentially the same thing, right? So pandas will provide separate functions for these different plot types. So it just gives us a different syntax to create them. I don't know that there's any significant difference between those two styles, so you can use either. I guess I tend to gravitate towards just calling the functions, because then I don't have to type all this other stuff. And there are going to be lots of different types that we can draw here. So if I want to go with a bar H, let's see what that is. Okay, a bar H is a horizontal bar graph. So by default, the bar graphs draw those bars vertically, and bar H will draw them horizontally, which kind of makes sense. Let's try an area plot. So I just changed that to area. And that now we're back to like a line plot here, but it's filling in everything below the line. So if that's useful for the kind of data that you're wanting to represent, then that's another option for you. There are going to be a whole bunch more of these. We're not going to get into a lot of them, but before we go on to any others, let's take a closer look at some of the ways we can configure these plots after we've created them, after we've rendered them. So let's just go back to a good old bar plot here, and let's check out some of the other arguments that I can pass in. So one of the things is that if I just get this bar chart, this bar plot out of context, I have no idea what we're even looking at. So let's add a title. So we can say overall grades and re-render that. And so now we get a nice looking title up at the top. I'm also getting some output here that's sort of summarizing some of the attributes of this particular plot. One of the things that's interesting about the labels here is that down at the bottom, over here at the x-axis, I have a label saying that these are the students, right? And you can change that label with attributes, and you can also add a label to the y-axis over here. Sorry, I lost my train of thought for a second. So we can say x label, and x label. If I say, well, I've already got an x label. I just pointed that out. But maybe student. I might call it students, or I might call it name, right? Student's name. And then I don't have by default any kind of a y label. So that y label over there is their grade. So let's go ahead and render that and see how it looks. All right, that's starting to look pretty good. We do have a legend up here in the top right corner, and it's when you're only plotting kind of one piece of data, it's all blue, and it's obvious, these are the overall grades. There's no real reason to have that legend there. So there's an attribute that lets us toggle that off. It's legend, and it takes a Boolean, so legend equals false. There we go. So we haven't changed anything about the data itself or about the way it's being rendered, but we've given it some things to make it look a little prettier, to make it a little more user-friendly or reader-friendly, I guess you might say. All right, so we jumped right into using this data without taking a look at what is actually in that Excel file. So I have opened it up here, and this is probably pretty much what you were expecting for the data that we were working on. What I've added here is that this one has additional tabs. I don't know if we'll really use both of them here, but I added some additional sheets here so that we can try importing from another part of that spreadsheet and make sure we understand how that works. And so I've got the weekly grade. It's called weekly grades, assuming there's one test per week. We've got 12 tests and then an overall grade that is actually matches what we have on this first one. And then we have those overall grades given to us in letter form. So just some made up data that's related to classrooms. I figured that's easy for students to relate to, right? So at this point, let's we want to get to some more interesting kinds of visualizations. We need slightly more complicated data. So let's take a look at those weekly test grades and see what we can do with that. So I'm going to create a new data frame for this. Weekly equals PD read Excel. Sorry, I'm trying to keep the font size big enough to see, but that makes it hard to see all the visualizations. And again, we're going to go with grades.slsx, and then I'm going to add the attribute sheet name equals, and this has to match what is in the Excel file. It's called weekly, and I believe it's going to be case sensitive, so I have a capital W in that. And let me just render that and see if that works, first of all. Okay, that did work. And we do have that same thing where we've got a perfectly good index value already in our data. This student ID would work as an index, and then we don't need these separate integer numbers that the data frame constructor or the data frame class has by default. So let's go ahead and set the index again. And this one is going to be student ID, it looks like what it's called, and we'll say that it is in place as well. Sorry that the attempt to be helpful by Visual Studio Code is getting in the way here. So this is what I've got. Set the index to student ID with the in place argument set to true. And it shouldn't be a big change here. We should just be getting rid of that default integer indexes. There we go. And so that also makes it fit a little better on the screen. So we've got student ID as an index, and the columns we have are the student's name, and then these 12 test scores, and then the overall grade for each student. And this is, so it's one of the things we have to learn when we're working with these data sets is that often we have very, very big sets of data. When we're showing a video, that data can be a little bit overwhelming. So this is still a relatively small set of data here, but I do want to show some of the things we can do to help us manage the data when it starts to get big. So one of the things I'm going to do is I'm going to make another data frame that is a subset of this. And let's say that I really just want to see how students were doing in the first month of the class, which would be these first 4 tests. And so I can do that. I'm going to call this, I'll just call it first 4, not the most inspired name. But I'm going to take that data frame weekly, and using that nested bracket syntax, I'm going to give it a list of the columns that I want. So I'll keep the student's name, and I'll take test 1, test 2, these are going to be case sensitive, so I got to be careful how I type them. Test 3 and test 4. And let's go ahead and render that and see, just take a look at how it is looking. Okay, so I've already cut down, I've gotten rid of some of that extraneous stuff that I don't need to look at for this particular analysis. Again, we just want to know how the students were doing the first month. That occurs to me that would be a much better name for this. Let's call it, in fact, I'll skip the DF and just call it first month. Okay, first month. So that's going to be our data frame for that first month. And I'm going to go ahead and set the index here. We've got that student ID that we might as well be using as an index. I'm not 100% sure if I need to do that when I've already kind of set it in the initial data frame, but just in case, I'll go ahead and set that. And I don't think that will have changed anything, but let me just, I always like to run my code frequently and make sure I haven't broken anything. So, all right, that's the way I'm wanting this data to look at the moment. And I just want to test this by kind of slicing out a couple of those rows and see if we can just see if we're able to just reference a couple of students. So I'm going to use the test that index essentially by using the loc method, and I'll use the nested brackets here, and I'm going to give it just a couple names. The first one is Jeff N right there, and then we'll go with Johnny B, and let's render that. Okay, so I just am confirming that everything is working the way that I want it to work. A couple other things you can be a couple tips, I guess, for when you're working with a big data set. And again, this really isn't a big data set by any stretch of the imagination, but if you have a big set of data and you're setting things up, you're kind of getting to know it and figuring out what you want to do with it. You don't want to have it rendering all this stuff, and in fact, there will be a limit to what gets rendered on your screen, and it'll sort of cut and skip to the end. But if we want to have some control over that, there is a head function. So that will give me like the first however many records that I want, or rows that I want. So if I put first month dot head 2, then I get the first 2 records, right? Obviously, if I give it 5 or something like that. If I don't give it any argument there, it defaults to 5. So that's the same thing. And I can there's kind of an equivalent for the end of the last handful of rows. If I say tail 2, that gives me the last 2. And so that's useful just when you're kind of working through stuff and you're figuring out what you want to do, and you don't want your data frames taking up your whole screen. That can be helpful for us. And one of the things you can do now is, of course, in Python, this is real common, is that we can just start, we can use that, and I don't need to save it into a variable. I can just plot it. I can just plot that, and that gives me, we're back to a basic line plot here. So this is, it's the first month of the semester, the first 4 tests, and it is just the first 5 students of data. And I've got, if you remember back to when we first started, the very first one we plotted, it's the same kind of thing. This isn't a real useful plot. It's, for one thing, it's messy, but it also doesn't make sense to kind of go across horizontally looking at students like that. What we might want to do is kind of swap those 2 axes, right? And we can call that transposing our data, right? Transpose means to kind of flip it from one axis to the other. And that's a common enough need that there are, so there's a transpose method. You might also, by the way, see there was a function called swap axes, I think, and you could use that to swap. My understanding is that is deprecated now, meaning we're not supposed to use that anymore. It probably still works, but they want us using transpose now. And so what we did by doing this is that now, instead of having tests going across the top as columns, we have the tests as rows, and we have the students as our columns. And transposing is a common enough need that they actually have like a little attribute we can use to access that. It's just a capital T. And so putting that capital T is just, you can think of it like an alias, I guess, for that transpose method. And now I can plot that. So I can just start chaining these references onto each other with dot notation. Okay, so now I've got my grades showing on the left. I've got the test numbers running across the x-axis at the bottom, and then I've got these lines of different colors representing each student. So this is starting to be a little more coherent, a little more useful to me as a data analysis tool, right? Because I can trace the blue line and see how Jeff has done over time. I can see with the green line how Janelle has done. There's no very good pattern here because I just used random data. I just used random numbers for my data. But this would be a useful way to spot trends. One thing about this is that this is a fairly kind of visually busy rendering. And so just showing you one more little option you can add is we can use subplots instead of the overall plot. And this isn't a subplot like in your favorite movie. In this case, what it means is that instead of rendering those all in the same space, we'll have a bunch of different plots, one for each student, right? So now that makes it even a little easier to sort of see Okay, so there's still the tests going across the bottom, but I can look at each student individually. And again, it's just another option that you have at your disposal. Okay, and I know my videos tend to go long. I'm jealous of the people I see on YouTube that can make these nice, concise videos. But then I spend time talking about stuff like this instead of just getting to the point. But I am going to do, I think, just one more. I want to show one that's maybe a little more interesting, or a type of visualization you maybe haven't seen before, um, and show you how to do that. And then after that, I'll shut my mouth and let you guys try stuff on your own. So let me add one more little code cell here. And this one is called a box plot, or sometimes it's called a whisker plot. In pandas, they refer to it as a box plot. I've always heard it called a whisker plot. And it's good for showing kind of the way data is distributed. And it helps us kind of see an overall kind of pattern, and it helps us see where the outliers are in our data. And so let's go with first month dot box plot. And notice, by the way, this one is an exception. This isn't dot plot dot box plot. This is just data frame dot box plot. And let's render that and see what we get. So this is a whisker plot. It's the layout here, because I've still got my transposed data. I think we're still, I guess I'm not transposed anymore. This is just the way the box plot rendered it. The idea here is I've got my grading scale over on the left, and then for each test I've got a representation for how the scores fell statistically. And so it helps to understand kind of what we're looking at here. The idea is that this box for test 1, this rectangle, it says that 50% of the scores in the entire class or the entire data set fell within that box, right? And it actually occurs to me, well, I guess I can get to that. 50% of the scores fell within that box. And so in other words, we might say, well, most of the scores are right in here. And for test 2, most of the scores are right in here. The green line, I don't know how well the colors show up on the video, but the line across it, that's the median value. So median is a type of average. So we might say that the average score, technically the median score, was right here. It looks like it's maybe just below 90 in this case. Okay, and what that means then is that from the median score to the top of the box, there 25% of the students scored right there. And from the median score down to the bottom of the box, 25% of the students scored right there. So that's 50%. That also suggests that then the rest of the students fell outside of this. What the whiskers are used to represent, the reason this is called a whisker plot or a whisker chart, is these little extensions to our rectangles with the whiskers sticking out of them. So those represent minimum and maximum values. So there's a maximum value of 100. Somebody got 100, at least one person got 100 on this test. And somebody got as low as, I don't know, looks like maybe 45 or so. And so that's the minimum. And then it excludes outliers. So in test 2, there were 2 scores that were just vastly different than the rest of the group. And so those aren't accounted for in the rest of the data. They just get separate dots to show that, oh, by the way, here were these 2 students that did really, really poorly. This one, maybe was absent on the day of the test. They got a 0. And this student, I don't know why, but maybe they were absent in the days leading up to the test or something like that. So it gives us a nice compact way of looking at all this data. And as an example of how I can use this in my analysis, and I'm by no means a fancy analytics guy, but what this type of data can tell us is I can look at this, and from this I can infer that, well, the test 2 was probably the easiest test because 50% of the students got at least, whatever that is, 75 on it. And it doesn't necessarily have the really high scores, but everybody, as a rule, did pretty well. The hardest test overall, I would say, is test 3, because It's got the bunching, the grouping kind of the lowest on here, and you can see the median score is way down here at maybe a high D or right around a C. So that probably was the hardest of my tests. Test one has the biggest kind of range of scores. And so I don't know what happened there. Maybe there were some questions on there that students were kind of either they knew it or they didn't, right? And so there's this big difference between the high scores and the low scores. And so something like a whisker plot is a little more complicated to read, but once you understand how it works, you can see patterns in the data in a really concise way, and then you can draw conclusions on those. Okay, so at the end of every video I record, it seems like I find myself saying, well, you know what, this is a really big topic and we've just done a tiny little bit of it. And here we are again, and I'm going to say the exact same thing. Analytics really should be a class all by itself. Analyzing data with Python, that, in fact, that is a class. I think I've mentioned that before. So we just don't have the time in this course to get into it. I think that you can learn a lot, especially if you don't have an analytics background. You can learn a lot just by pulling in some data and trying out these different plot styles, these different, the different types of plots you can generate and the different options you have access to with those arguments. And you can kind of try them out and see like, well, what does this show me? What am I able to determine by looking at this? If you do have a background in data analysis or data science, then you certainly will know kind of what you want to see and how you want to represent the data. So for you folks, it's really more of a question of like, well, how do I get pandas to do that for me? And there are a lot of great resources for that. Inside Canvas, I have linked to the official pandas documentation. And if all you want is to just go and see like, how do I do this? That's a good way to look things up. There are some great video series on this. I'm going to link those in Canvas as well, so that if you want to get deeper into this, I think it's fun. I think it's interesting to look at. But hopefully this gives you just a little bit of an introduction to it, and hopefully you have fun now trying out the different visualizations and seeing what you can do with it. As always, reach out if you have any questions.